Hello YouTube, my name is Bernard McManus and I'm showing you my Boxland software once again. This is the latest iteration. It's a simulator for the insides of a box. The cubes move around, eat, try not to get eaten. They make decisions in the database and they are scored actually on the Java side. So there's actually a neat split between um, what the database is doing and then how Java can actually judge how well it's doing for its decisions. So that was part of bringing these stats up to the screen. So I've got four teams, blue, red, yellow, and white, as well as the green plants that pop up whenever they're eaten. The four teams now have different AI algorithms that they use to make their decisions. So when they get to a space, they look around on each of their edges, so they can only look in one square and they can't look diagonally. They look around and then they think, all right, well, what have I done in the past that has led to bad decisions? And they try to discard those and then choose randomly from what's left. And over time, they're trying to stay well fed. They're trying not to die. Basically, the only feedback is if somebody dies, they have to figure out what happened, why that was bad, and how they should avoid it in the future. So, of the four teams, blue is actually making their decisions completely randomly. You should see blue cubes just drifting around the board all the time. The red are slightly smarter, and actually it's turned out to be a really effective algorithm, which is just the option-based decision making. If they see a green plant, usually it's a good idea to eat a green plant as opposed to move around, as opposed to attack somebody or stand still and let the guy next to you eat you. So usually you should eat that plant. The yellow team is state-based, so they're actually recording every state. So when they look around and look around them and see what's there, they record that state, and they will recognize when they're in a similar state as a block before and see what bad decisions were made, because it only weighs the bad decisions. And so it actually has to learn, and it has to learn each of the sides. It has to learn each of the edges and each of the corners. Some of the sides are equivalent to the other ones, but generally if it goes into a corner that nobody's ever been in and then died, it will have no information on what to do, but generally that could mean maybe it's always good to be in the corner, who knows. So that's the state-based, and that's yellow. And then white has a combination, so it actually starts with state-based and then it throws out all the decisions it doesn't like, and then it uses the choice weighting to decide what's left. So it might look around and say, okay, well, if I stood still here, I died, so I should move. And then it looks at the choices and sees, oh, actually there's a plant I could eat, maybe I should do that. So in theory, the white line, if I do my job right, the white line should be the best. In, I'd say, 4 out of 5 simulations that I run, it usually comes out on top. The red line, which is the choice-based decisions, is actually really effective, and in this game, I think it ends up winning. I think even by 20,000 steps, it's still ahead. So just the straight up, like, is it a plant? Yes, eat it. Is it an enemy, or is it a blank space, or should I stand still? That just keeping it very basic seems to be an effective way to survive in Boxland. So at this point, I'm really happy where the simulation is. This is where I wanted to get. I wanted to be able to play around with different database scripts and algorithms and see if I could come up with smarter ways of doing it, or find techniques that databases can use to do better machine learning. I really take advantage. It'd be hard to port. I keep thinking it'd be hard to port the logic back out to Java so that this can just run on its own, because the logic behind the AI really takes advantage of how databases work. Although there isn't as much data being saved as I thought, so it would be possible to create memory structures and deal with it, but the database, it gives me great flexibility to do whatever I want with my scripting and have it be very high performance. I mean, the frame rate is great here for how much processing and the complexity of the processing that's being done in the background. All right, well, I hope you enjoyed it. I hope you found it mesmerizing and the text isn't too small. I'll see if I keep improving this, and I'll post more videos. Thanks a lot.